Hi everyone, Radko Tutor here explaining. In this video, we are going to look at Laplace transforms. So when we talk about Laplace transforms, we are simply talking about these ones that I've written here. So these are what we call as the Laplace transforms. So what happens is that you are given these that are given to your left hand side, which are actually equivalent or equal to these that are to your right hand side. So in other words, instead of you using Laplace of 1, you can simply use 1 over s as its transform. And instead of you using maybe t to the power n, you can simply use n factorial over s to the power n plus 1 as its transform. So we are transforming something from what is given as this to that. That's what we mean under Laplace transforms. So in other words, for you to be able to solve questions on this topic, you must first know the Laplace transforms which are given here. So these Laplace transforms are very, very important because without knowing these, you cannot be able to solve questions on Laplace. So first start by knowing these Laplace transforms, then now questions on Laplace will become very easy for you to solve. Alright, having laid that foundation, let's try to see how we can simply solve questions on the Laplace transform. So with me here, I have these questions. The first one, we are saying that evaluate the following. So we are evaluating, the first question is evaluate the Laplace of 3t minus 7 sine 2t. Now, as you can see, we are given these brackets, and whenever you are given Laplace, you can start by simply multiplying that Laplace throughout what is given in the brackets. So to do that, you are going to multiply Laplace times 3t. You are going to have Laplace of 3t. Then you can also say minus Laplace times 7 sine t. We are going to have Laplace of 7 sine 2t. Then after you've done that, always make sure that the constants are factored out. So the constants must be factored out whenever you are solving these Laplace transforms. So here we have the constant of 3, there we have a constant of 7. So to do that, you can simply say this is the same as 3 Laplace of t. So you can remain with a t there. Then minus Laplace, you come here. What is our constant? Our constant is 7. So you can say 7 is our constant, and then you remain with Laplace of sine 2t, like that. Now, to finish this out, what you can simply do is you can relate what is left inside the brackets with the transforms that you know. So we know that if you are given a transform of t, do we have any transform of t from these transforms? Yes, you have transform of t to the power n. So since we have only t in our question, meaning that t is the same as power 1 there. Okay, so we have transform of t to the power n, and our n in that case is 1. So what is transform of t to the power n? Transform of t to the power n, we know that it is n factorial over s to the power n plus 1. So you can simply replace this, you can simply replace the Laplace of t to the power n as n factorial over, we are saying it is n factorial over s to the power n plus 1. So s to the power n plus 1, like that. Then minus, you can also do the same here. You say 7, the Laplace of sine 2t is given as you go and check on your Laplaces. Do we have any Laplace of sine? Yes, it's this one here. And the 2 is this a that is given. So Laplace of sine at, which is this a is representing any constant put in the question. So if you have Laplace of sine at, the Laplace that you get, or the transform that you get, is a over s squared plus s squared. So you can put a over s squared plus a squared. That's what we have. So in this case, you just need to replace the transforms. So the transforms that you need to replace, or rather the numbers that you need to replace. So you have 3 open. What is our n factorial? Our n in this case is a 1. So you put 1 there, factorial over s to the power. What is our n? Our n is this one. So you put 1 plus 1. Then minus 7, open, you have our a. What is our a in this case? A is that 2 there. So you put a 2 over s squared plus a is 2. So you put 2 squared, like that. All right. So now after you've done that, what you can simply do is you say 3 open, what is 1 factorial on top there? 1 factorial is 1 over s to the power 1 plus 1 is s squared. Then minus 7, here you have 2 over, or we can simply multiply that if we want, or you can just leave it like the way it is, which is 2 over s squared plus 2 squared is a 4, like that. Then you can multiply the constants. So by multiplying the constants, you are going to have 3 times 1 is a 3 over s squared minus 7 times 2 is a 14 over s squared plus 4, like that. So that means this becomes our final answer if we are to solve this Laplace transform question like that. So what is important is you need to understand the transforms given on each. So what will be given always is that they'll be giving you these transforms and see if you are able to transform them to what is to the right hand side. All right, so that's how you can do that. Let's go to our question number 2 and see how we can do it. So our question number 2, which is B in this case. So our question number B is Laplace of 3t minus 7 sine 2t. That is our question number. No, let's not use this one. This one is the one that we are from solving. So our question number B, we are going to have cos of 40 minus, or maybe I can put a plus a e 2t, like that. So what I've said is that you start by always checking if you have constants. Do you have constants? No. If you don't have constants, you multiply the Laplace throughout there. So you multiply Laplace times cos 40, you're going to have Laplace of cos 40. Then you do that. And then you say plus, you also multiply Laplace to that, you get Laplace of e to the power 2t. Then now you need to check on your transforms. Mind you, no one will tell you that this is the transform. You are supposed to know them by yourself. So you need to know that the transform of this, you are supposed to know it, transform of that, you are supposed to know it. So if you check on these transforms that I've given you on top, you are going to find that there is also a Laplace of cos 40 or cos 80. You also have a Laplace of e or exponential 80. So you check, you need just to replace here. So you check what is Laplace of cos 80. Laplace of cos 80 is given to be here, that is s over s squared plus s squared. So you put s, so you are going to put s, so we are going to put s, this one you put s over s squared plus s squared. That's the Laplace of cos 80. Then plus Laplace of e to the power 2t, Laplace of e to the power 2t is given as, you are also having Laplace of e to the power 80, which is given as 1 over s minus a. So this way is supposed to be s minus a here. Okay, s minus a. Let me just write for you. That is s minus a there. Okay, so where we have e to the power 2t, we put s over s minus a, like that. That is the Laplace, oh sorry, it's 1 over s minus a. That's the Laplace of e to the power 80. All right, then from here, what we can simply do is now to replace the values. So what is s? S in this case is never replaced, so you just leave it like the way it is. That is s, then over s squared also is s squared plus s squared. Our a in this case is 4. So if you say 4 squared, you get a 16. Then plus, here also you have 1 over s minus, what's our a? Our a in that case is that this 2 which is here, because we know that it is e to the power 80. So our a is, we are going to put that as a 2. So that means this becomes our final answer if we are to solve this Laplace transform like that. All right, let's look at this other one here. So this is our question C. So now how can we solve this? We can just replace the Laplaces, but before replacing the Laplaces, we can simply multiply the Laplace outside with what is inside. So to do that, you can say Laplace times e to power negative 2t is Laplace of e negative 2t. And then minus Laplace of that is Laplace of sine t. Then from there you can from here, what you can do now is you can check the Laplaces. What is Laplace of e to power at and what is Laplace of sine t? So in this case, since this one is only sine t, remember on the Laplace on the Laplaces we have sine at. Now in this case, here this one is only written as t, meaning that the a there is 1. So in other words, it was supposed to be Laplace of sine 1t, but you cannot write 1t. You just write sine t. So now in this case, what you can do is you say Laplace of e to power negative 2t is 1 over s minus a, and minus Laplace of sine t. Laplace of sine t, we've said that it is a over s plus a squared, like that. So that's the Laplace of sine at, which is this one here. Okay, as given here, we are saying that Laplace of sine at is a over s squared plus a squared. That's what I've written. Then now you need to replace the numbers. So we know that our a in this case is negative 2t. So you can say 1 over s minus, what is our a? Negative 2, minus, what is our a here? From the other side, our a is 1, because we are saying that it is a Laplace of sine t, which is supposed to be Laplace of sine 1t. So our a in that case is 1 over s squared plus, what is our a? Is 1 squared. Okay, then from here we say this is 1 over s, negative or negative is s plus 2, minus 1 over s squared is going to give us s squared plus 1 squared is 1. So basically this is going to be our final answer. That's how you can get that one correct. All right, now for you to be able to answer this one as well, you should make sure that okay, so you should make sure that you follow the same procedure. So you also need to follow the same procedure, or this is the same question. So let me just give you some tasks that you're supposed to do. So you can do the Laplace of 3s or cos h 3t minus e to the power negative 3t, like that. So you can do this one as a task, and then feel free to inbox me to see if the answer you've gotten is correct. Thank you so much for watching my videos. Please don't forget to subscribe so that whenever I post videos, you are notified that I've posted videos. If you are on Facebook, kindly follow my page for more videos. See you next time. Bye bye.